Alright, so we're going to start our topic on plate tectonics with a quick talk about the man, Alfred Wegener. It's spelled Wegener, but it's pronounced Alfred Wegener. He was a German man, a German meteorologist and astrophysicist, mostly meteorologist, who made possibly the most shocking discoveries in all of geology. He really turned the world on its head. Well, he would have if anyone listened to him. So what were they thinking in the early 20th century? And this is the early 1900s for those of you who aren't so sure on that sort of stuff. Well, first, the continents and the oceans, their position was thought to be fairly static, so not moving. But they believed they could subside or rise in or out of the planet, and that's called subsidence. So they could go up or down, but they never went laterally sideways. Mountain building was caused because they thought the Earth was shrinking, so it's collapsing in on itself. And as it collapsed in on itself, parts, when they came pushing together, buckled up, and that's where they thought mountains were being built from. And subsidence was the cause of land bridges. So essentially, we know that between here and here, there are kangaroos. We're not the only country with kangaroos. There are kangaroos between here and Papua New Guinea. But how did they get there? So they believed that these land bridges would again come up out of the ocean and then sink back down. And we'll see how that ended up. Now, I think there's subsidence of land coming up and down, and I want you to think about which myth this sounds like, and maybe that's a reason that culturally that myth actually hung around for a very, very long time. So, there was one very serious early problem, and that is in the 1850s, there was a solid understanding of evolution occurred, and one of the guys who worked with Charles Darwin, who's not partnered, but co-discovered evolution by natural selection with Charles Darwin, was a guy called Alfred Russel Wallace, and he spent a lot of time in Malaysia and Papua New Guinea, this whole area down here near the top of Australia. And what he noticed was that between this area, you didn't get much, but on this side, it was full of cats, tigers, and basically what we call placental mammals. Now, a placental mammal is a mammal that grows inside the womb, and when it's born, so it's basically grown inside the mother. But on the other side of this line, there's a very clear line, there's a very clear area, just to the left, or to the right of it, sorry, to the east. Everything had pouches. They were all marsupials. There are no native placental mammals in all of New Guinea, Australia, with the exception of some bats, which can fly from place to place. There was nothing, only marsupials. So, yeah, and that was a problem. If there were land bridges, why were these guys able to get all the way down here, and why were marsupials able to get all the way up here? But they never crossed this deep trench. All right. So, Alfred Wegener, who was he? He was a German astrophysicist and meteorologist, geologist, sort of. He had some very important geological ideas, and that's what he's remembered for. But his working life as a scientist, he was a meteorologist. He was born in Berlin in 1880, and he died as a bit of an adventure scientist. He was on an expedition to the Greenland ice sheet, and in 1930 he had a heart attack, they think, on the Greenland ice sheet, and that's where he died at 50. So he was a fairly young guy. After making several observations, which we'll talk about in a second, he devised the hypothesis of continental drift. Now, it was a hypothesis. It's a theory. Now, plate tectonics is a theory, which means it's fairly well shown to be true, but it was a hypothesis at the time. So his ideas were swiftly rejected. They sort of out of hand. They just kind of went, that's crazy talk. He was proven to be right, though, and by this I mean correct. And his ideas were stunning, given the time and the current climate. Now, we won't go into why his ideas were rejected. That's for class, and we'll get to that. So, the hypothesis of continental drift. So, over time, basically the continents moved in relation to one another across the surface of the Earth. Now, that's new because, again, they thought up and down maybe, but he's saying sideways in relation to one another. Now, I want you to think about this. We tend to say our hypotheses with an if and a then statement. So, if something is true, comma, then you make a prediction. This will happen. So, I want you to frame that and bring that to class tomorrow. I want you to frame that as an if and then statement. And here's a modern interpretation of it. So if you go back 225 million years ago, it was all one big landmass, and then it breaks up over the next 100 million years or so into Laurasia, which has Eurasia, so Europe and Asia, and North America, into Gondwana land, which has most of the other ones. So Africa, South America, Australia, Antarctica, etc. And that breaks apart India. And here we have what's starting to look a bit more what we're used to, and here's today. Alright, so his observations. First, South America and Africa. If you go along here, and you go along here, they fit together as though it was a newspaper that was torn up. And here's what those two continents look like if you put them together. We'll play around with some of the continents, and we'll put them together as a puzzle, see if you can get it right. Mountain ranges. Well, you found that a lot of mountain ranges were restricted to continental boundaries. So if the Earth was shrinking, as they thought, there's no reason for them to be constricted to these edges of continents. But he realized that all of the major mountain ranges, the Himalayas, etc., they all come together around the continental boundaries. Sorry, that was distracting. Isostasy. So basically, isostasy refers to how things float in relation to how dense they are. And he realized that there was an equilibrium between the crustal plates. They go sideways. They don't go up and down over time. So you can account for an area getting lower due to erosion, but they stay at the same sea level essentially for always. Fossil distribution, and in particular, he was dealing with Mesosaurus down here. So what they would find is that certain fossils were found here on the edge of one continent and then on the edge of another, and that's, and here we find one fossil here and one fossil here, and then there's a Glossopteris that shows how all of Gondwana land was put together, because it's a fossil that is found in a pattern that neatly takes in how all of the continents were joined together. So you found similar fossils on either side of continental boundaries that aren't connected anymore. This one's really interesting. Distribution of climatic indicators, and what this means. So the climate has changed, aside from human-induced global warming, which is happening. We also have the climate changing over time. Now, if you look at this fern is found in Antarctica, this fossil, and it's a subtropical fern. And what that means is that Antarctica is not where it always was, so it's in a drastically different position to where this fossil was first formed 350 million years ago. And that is before it was in an area beneath the tropics, just beneath the tropics, whereas now Antarctica is at the poles, so it's frozen. No plants can grow there. Well, certainly not ferns. So, yeah, the indicators show that the climate was different there, and the only way you're going to get climates that are that different is by moving them to different positions on the globe. So that's him, and we're going to talk a bit more about it tomorrow in class. But before you come to class tomorrow, you also need to be aware that there are two types of crust. You have, like for example, the oceanic, the Nazca plates. They are, Pacific and the Nazca plates. They're oceanic plates. And if you go here to, pick one, they're all over the place. So Eurasian plates, that is a crustal plate. Okay, continental plate. And here we have a continental plate, etc. Here we have an oceanic plate, crustal plate, oceanic plate, and that's a crustal plate as well, and so forth. So there are two different types of crust. All right. You need to, as well as having taken notes, you need to think about what are the reasons that he would have been rejected. Now you can look them up. That's what I would suggest doing, or you can find them. You can have a think about it on your own. Maybe do both. All right. So bring those to class tomorrow. Stay rad, and yeah, good luck.